This problem describes the motion, say, between two people, A and B. Person B here, when at t is equal to 0, say when some clock starts, is 2.4 meters from some origin, from x equals 0, 2.4 meters away, and they're moving at 36 miles per hour. Person B, a half hour later, they're at the origin, moving at 50 miles per hour. So it's sort of an awkward problem to visualize here, but it sort of works like this. If you had some big old clock up here, the sort of telling time right here, when the clock said t is equal to 0, you would see that person B is right here. This is the origin right here. Person B would be at 2.4 meters. And don't know the significance of that, but that's just what it's stating here. And then when the clock keeps ticking, so when the t here is no longer 0, but say the clock ticks to 0.5 hours, like a half hour later goes by, what you would see is because this person here is moving at 36 miles per hour, they're going to be way down here. Who even knows where they are a half hour later? But this other person right here is going to be at the origin right here. So this is where A is going to be right here. But again, that's later, a half hour later. So it's a bit problematic with this staggering of the clock and stuff. I just want to show you maybe a quick and intuitive way of getting something like this to work out. So when they're going to meet really is an issue. When is A's position equal to B's position? So you need to find some way of filling in both sides of this. So let's see if we can find out what A's position will be. So this issue, A is the one that is sort of at the origin a half hour later. So what I would do to handle a problem like this, I would just ensure one way or the other that no matter what I write down, when I plug in 1/2 for the time on person A, I get 0. Sort of like checking my result like that without too much worrying about the logic too much in there. Now I know some things about motion here. I know, for instance, that x is x0 plus v0 delta t plus 1/2 a delta t squared. This is equation 1 that we're dancing around with here. Now I can immediately cross out this term because it doesn't say anything about them accelerating, so that's going to be 0. But the issue again is what do I do with the x0 and v0 stuff? Well, we're pretty sure that the v0 here is going to be the 50 because it doesn't say anything about them starting from rest or doing anything. All we know is that they have the speed of 50 miles per hour. And I don't really know what to put in for x0 because I don't know where the person starts. Again, all I know is that when I put in 0.5 in for their time, I really want to get 0 out. So let's just go for that then. I can do it a couple of ways here. I can say this will certainly work too. I can just assume they started at 0 somehow. I don't know how that would work. And put in the 50 here and put in something like a delta t minus 0.5. Okay, I can just go ahead and stagger their time variable with that time lag of a half hour. So you'd have to agree that if I put a half hour in for this, I'd get 0.5 minus 0.5 or 0, so XA would be 0 at a half hour, and that's totally consistent with this information that the problem gave you up here. Another way you could form it is you could say, well, all right, I don't like subtracting times in here, so the person's position at A then is going to be their initial position. I'll go ahead and put in a something for x0 here, but I know that v0 again is going to be 50 times delta t. Okay, that's the x equals x0 plus v0 delta t, and again the half at squared term is 0 because there is no acceleration. So when I put a 0 in for time, once again on this, I want to get, when I put in a half hour for time on the x of A here, I want to get that 0 out once again. How could I do that? Well, if I put a 0.5 in for delta t, 50 times 0.5 is 25, so I'd have to put a minus 25 in here in order to make xa 0 when delta t is 0.5, just following the information. So either one of these equations would work, and if you sort of notice cleverly, they're actually the same equation, 50 delta t minus 25, 50 delta t minus 25. So just two ways of getting the same result. We'll just focus on this one. Now the other person is a bit easier here because they don't really have any sort of time shifting and stuff like that going on, but if you look at it here, they're at 2.4 when time is equal to 0 with that velocity that they're given us. So this one's kind of straightforward to put in here, so we'll just sort of call it x sub b. That's where person B is right there. And I don't know really where they start, but again, I want to form an equation that when I put 0 in for time, I get 2.4 out. So I'll go ahead, this one's probably more intuitive here. I'll put the 2.4, x equals to x0 plus 36, that's their v0, times delta t. And again, there would be a half at squared term out here, but it's not there because a is 0. This equation, I hope you agree, if I evaluate at 0, I'll get 2.4 out as the information demands. If I put a 0 in for delta t, I'll get a 2.4 out. So I think this equation is going to be valid and work for me. Now all you have to do then to figure out when they're going to meet is to realize, okay, look, I've got xa and x sub b now, and my original meeting condition for them is when x sub a equals to x sub b. And so if you put all that together there, you should be able to algebraically solve for a delta t. That'll be a time when they meet. You get some number for that. There won't be any other variables. You can go ahead and plug in your calculator and do some algebra to solve that. If you want to know where they'll meet now, that's the time. If you want to know where they'll meet, you can plug into either one of these equations right here, the delta t you just solved for. So you can take the delta t now, if you want to know where they'll meet, and plug in either for this one or for this one. Which one do you choose? They're going to be the same. This is a very special delta t. This is when x of a is equal to x of b. So you can plug into either one of these to figure out exactly what that meeting position would be.